Greetings and welcome, ladies and gentlemen. We're talking about Necap 2007, back in the day, 2007, sure. Problem number 6. And back in the day, our students in our school, 31% of them got this question right. And in the state, 34% of the students got this question right. What it's asking is, it says, what is the length in units, all right, because the x and y axes are labeled in scale but not in quantity. We don't know, I guess, what it's measured in. This isn't like in feet or something like that. So it's in units of segment, line segment, that's what that symbol means, of mn. So the segment going from point M to point N. All right, so this little segment right here, I want to know how long is that. Maybe you could kind of like imagine, like, what if I swung this over here? How long would it be here? And you could try to measure it, -7 to 3, and maybe you'd estimate something like that. You could use all sorts of strategies. Actually, since this doesn't specify that this is, sometimes problems will say not to scale, that actually wouldn't be a bad strategy. I would actually fold my paper right here, and I would trace it onto the grid here, and you actually would have gotten the right answer that way. That's interesting, because they didn't specify that it wasn't to scale. So that's kind of an unusual strategy you could have used. Not all the time would that work. But the strategy that likely they were going for was the distance formula, length and distance, kind of the same idea. And in order to do that, we're actually going to need to know the locations of M and N. What are the coordinates of M? 3, -1, right? So it looks like over 3, down 1. And what are the coordinates of N? Back 5, so -5 and -7. Okay, all right. And I believe we would have been required to know the distance formula for ourselves. I don't think they actually give it to us on the Necap test, or the SAT test for that matter. I don't think. So what is the distance formula? Well, I'll give it to you. The distance formula, capital D distance, is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So that's the first little nugget of truth you had to step into this problem with if you were to solve it properly. So let's actually figure out what x2, x1, y2, y1. Those are referring to the x coordinate of your second point, your x coordinate of your first point, your y coordinate of your second point, y coordinate of your first point. So the first thing I like to do is label my points. So I'm going to label this x1 and y1, and x2 and y2. And it actually doesn't matter. You could switch the names of these points to point 2 and point 1 instead of point 1 and point 2. That doesn't matter as long as you're consistent. All right, I can't call this x coordinate 1 and this y coordinate 2, for instance. That will screw up the formula. So let's plug this in. So the distance is equal to the square root of, let's see, x2 was -5, right? Minus x1 is 3, right? All squared, plus y2 is -7 minus y1 is -1 all squared. So let's simplify this. So this is the square root of -5 minus 3 is more negative. That's -8, right? Squared. Plus -7 minus a -1 will become +1. And that's going to be -6, I believe, if I'm not mistaken. Now, squaring these, actually just knowing what -8 squared sometimes can be a challenge for students. And if I didn't properly parenthesize this, if I can use parentheses as a verb, you would probably have a sign error there. But -8 all squared is +64. And -6 all squared is +36. Now, some people also will make a mistake here where they will incorrectly distribute a square root over addition. And they'll say, oh, that's the same as the square root of 64 plus the square root of 36. And those people are wrong. So we actually have to combine these insides first. And I'd get the square root of 100, which is equal to 10. revealing my answer. So it is a decent amount of work here. We did talk about the possibility of this being a right triangle, but that actually doesn't help us, so Pythagorean theorem isn't helpful in that sense. However, side note, I don't know if you guys know this, but the distance formula actually is the Pythagorean theorem. I don't know if you know that. Where this distance here is your x2 minus x1, and this distance, right, that's the difference of your x's, and this distance here is your y2 minus y1. And if I was to do plain old Pythagorean theorem, I would say that this distance c, I'd say c squared is equal to, let's see, this guy squared plus this guy squared. And then if I wanted to solve that for c, you could actually just root both sides, and behold, oh, that's not how you root both sides. You do this. Silly me. Technically, when you root, you'd also get plus or minus, but we're talking about distance here. We're not caring about negative. And notice that actually gives me the distance formula there. So that's where the distance formula comes from. It's just a first cousin of the Pythagorean theorem. It's just like one step away from it is really what it is. So so that's how you'd solve this problem. The correct answer was D. Bam. So that's the proper technique. Thanks for watching, everybody. Bye-bye.